In industrial steam plants, what facility managers classify as routine maintenance is actually a massive, undocumented thermal leak. The specific symptom of this leak is the manual purging of heated boiler water to control total dissolved solids, or TDS. The structural flaw lies in the schedule. Manual blowdown relies on static shift rotations to manage highly dynamic thermodynamic variables. Operators lack real-time feedback on the internal water chemistry. Without exact measurements, they manage the boiler strictly through the fear of catastrophic scaling. To ensure the pipes do not crystallize, operators intentionally overcompensate. They purge far more boiling water down the drain than is chemically necessary. The scale of this waste is staggering. This blind overcompensation forces a facility to burn between 1.3 and 5% of its total daily fuel consumption just to reheat cold makeup water. Relying on human discretion to map fluctuating thermodynamics is not an operator failure, it is a critical engineering flaw. The only way to eliminate this specific thermal waste is to achieve zero-latency thermodynamic control. This is the exact function of the Aegis TDS loop architecture. It operates by utilizing edge-computed logic to map digital sensor data directly to physical actuation valves. By closing this loop, the architecture replaces arbitrary human shift schedules with an unarguable, mathematically precise baseline. The physics of steam generation are absolute. As pure water evaporates, it leaves behind concentrating dissolved minerals. If the concentration of total dissolved solids exceeds the permissible limit, typically between 3,000 and 3,500 parts per million, the minerals crystallize. This crystallization forms a hard layer known as scale on the boiler tubes, acting as a highly effective thermal insulator. This cross-section shows the exact penalty of that insulation. A scale layer just 1 millimeter thick forces a water tube boiler to burn 2% more fuel to maintain the same steam output. True restorative engineering requires quantifying the leak before installing a single piece of new hardware. The required diagnostic tool is a 48-hour feed water and makeup water audit. Engineers must track the exact TDS parts per million at the feed water entry and weigh it against the facility's total steam output over 2 days. The delta between these two metrics reveals the undeniable baseline of thermal waste that the facility currently ignores. The physical parameters for intervention are highly specific. The Aegis system is a modular retrofit kit designed for 1 to 5 ton per hour industrial boilers. The installation begins with Step 1, isolate the variable. This milled aluminum probe is a high-temperature pH and conductivity sensor installed directly into the continuous blowdown line to capture real-time TDS. Step 2 of the build is automate the actuation. This requires mounting a heavy-duty, matte black automated proportional valve onto the blowdown exit pipe. Step 3 establishes the control logic, wiring the analytical probe and the mechanical actuator into a ruggedized programmable logic controller. The logic programmed into the PLC is strictly binary. The valve actuates exclusively when the specific TDS threshold is breached, and it seals instantly when safe levels return. Through this rigid 3-step hardware loop, human discretion and human error is permanently removed from the physical process. The mechanical hardware only represents half the architecture. The true invisible control point is the conductivity data stream itself. The digital layer of the Aegis system relies on a localized large language model, trained specifically to analyze the continuous sensor telemetry coming from the PLC. Standard industrial systems produce useless, overwhelming raw data dumps. This architecture processes the noise into highly specific outputs. The localized model is engineered to issue only actionable, daily predictive maintenance alerts. For example, the system will detect a subtle drop in upstream feed water quality before that water ever enters the boiler drum. Flagging this upstream shift early allows operators to adjust their chemical dosing before the TDS threshold is breached and scale has a chance to form. True intelligence in an industrial system does not simply react to present variables. It quietly secures the perimeter against future failures. Thermodynamic optimization translates into capital recovery through specific mathematical formulas. This formula calculates the strictly required blowdown mass. It divides the average steam generated per hour multiplied by the feed water TDS by the difference between the permissible boiler TDS and the feed water TDS. Subtract this required mass from the current manual blowdown rate. This yields the excess mass purged, the tonnage of boiling water wasted daily. The final payback equation multiplies excess mass by delta heat and fuel cost, divided by calorific value and efficiency. Facility managers use this exact thermodynamic calculus to prove the hardware intervention pays for itself through immediate fuel reduction. This calculus reveals a capital recovery cycle that often completes in under 6 months, making the hardware cost a secondary variable. For founders and integrators, the required operational mindset is critical. Do not sell the Aegis hardware as a one-off transaction. The intervention should be executed as an energy-as-a-service contract, installing the hardware at zero upfront cost to the facility. Monetization is achieved by securing a fixed percentage of the daily coal, oil, and water savings over a 36-month term, continually verified by the AI dashboard. The strongest industrial businesses prioritize capturing invisible control points over seeking attention. Whoever controls the sensor loop and the conductivity data stream dictates the facility's energy efficiency baseline, securing an asymmetric market advantage. The philosophy of restorative engineering dictates that technology should never be performative, and it should never exist simply for headlines. Technology must quietly secure perimeters, reduce operational physical risk, and restore industrial systems to their mathematical ideal. For plant operators and founders, the directive is clear. Conduct a 48-hour feed water variance audit. Isolate your physical variables and quantify your specific thermal leak. Remove human guesswork from your thermodynamic systems entirely. Long-term industrial